Hello, welcome to today's session. Today we are looking at the UTME Mathematics 2016. So we're starting from question number 1, and question number 1 says integrate 2x cubed plus 2x over x. Integrate 2x cubed plus 2x over x with respect to x. So solution, we have 2x cubed 2x cubed plus 2x over x. All right, with respect to x, we have to integrate this one with respect to x. So as you see, this is under integral calculus. I'm just going to give us a bit of introductions to it. So if you want to have an in-depth knowledge of it, you can go to you can refer to our subject by topic area, where you have an in-depth knowledge of it. But I'll still give you an introductions to what an integration is, and so that you can have a background to solving this question. So you know that in integration, if you have what we call a function of x dx, okay, which is something like let's say we have x raised to power n, and then we are differentiating this with respect to x, where n is the power of x. This is equals to x raised to power n plus 1 over n plus 1 plus a constant k. Remember that your integration is the opposite of your differentiation. Is what we call anti-differentiation. So that's why the constant is there, because if you have a constant, if you have an equation, say like 2x squared plus 4x plus 5, and then you differentiated it, this constant will not be accounted for. So when you are integrating it, trying to get back this equation, you need to put a constant there to account for any missing constant from the initial equation. So that's why we have the k there. Now this equation, very equation, is a joint equation. I'm going to split it. So solving this equation, coming back to our solution, the initial question, I would split this into 2x cubed over x plus 2x over x, then all the x, okay, which can be written down as 2x cubed over x dx plus integral of 2x over x dx. So you are having them individually. So this can also be written down as equals to, if you cancel this one, cancels one out of this, so you have 2x squared dx plus this cancels this, then 2 dx. Okay, now this is equals to if you apply this formulae up here, then you have your solutions to be equals to 2x. You have 2x to the power of 3, that's 2 plus 1, all over 2 plus 1, then plus k, that's, you can have that constant there, plus the coefficient of 2 here is x raised to the power of 0. Remember in mathematics that any number to the power of 0 apart from 0 is what? Is 1. So we would assume that 2 is the same thing as 2x raised to the power 0, such that when we integrate it, we are going to have 2x raised to the power 0 plus 1 all over 0 plus 1. So this invariably will give us 0 plus 1 is 1. So we have 2x, 0 plus 1 is 1, so 2x over 2x. So now if we integrate that, this is actually the integration. Now, so we have the solution to be equals to 2x plus k. Okay, now let me clear up the screen a bit so that we can have space to ourselves. Clear the screen a bit. Okay, now what we're saying is this is equals to, by the time you integrate it, we're going to have 2x raised to the power of 3, because 2 plus 1 is 3. Then you have 2x raised to the power of 3 over 3 plus 2x, this k plus k, that's constant plus constant is constant. It's not 2k plus what, or constant. So that is our answer. That is our answer. So you have 2x raised to the power 3 over 3 plus 2x. Like I said, if you want to have an in-depth knowledge of the integral calculus, feel free to go to the subjects by topic area. Just look for the integral calculus. We're going to break it down there. Then you come back here and see that the question is really very, very simple. Okay. Now, so if you look at your option, you have option A, 2x cube over 3 minus 2x plus k. Option B says is x raised to the power 3 plus 2x plus k. And option C says is 2x cubed over 3 plus 2x plus k. That is it. Option C. And then your D goes ahead and says x raised to the power 3 minus 2x plus k. But remember, I always told you, it's a function of the concept, not A, B, C. All right. Now, question number 2. Question number two says, if the mean of 4, y, 8, and 10 is 7. If the mean of 4, y, 8, and 10 is 7, find y. If the mean of 4, y, 8, and 10 is 7, find y. So we have 4, y, 8, and 10. Their mean is what? The mean is 7. So we have to find y. Remember, your mean, which is your average, is equals to mean, and if you call it your x bar, is equals to sum of fx all over sum of f. Invariably, what we are saying is you multiply the variables by the numbers they appear, divided by the summation of the appearance. So what we are going to do is, now we have 4 appearing only one time. So 4 times 1 plus y plus 8 plus 10 divided by the appearance. 4 appear only once, that's 1, 2, 3, 4. Divided by 4, all is equal to 7. Okay, now what we have is 4 plus 8, 12. 12 plus 10, we have 22. So we have, this is equals to 22, 22, okay, plus y over 4 is equals to 7. So what we're doing there is, you have your 22 plus y to be equals to 4 times 7, 28. So your y is equals to 28 minus 22. So your y equals to what? 6. Okay. Now, so if you look at the option, you have option A says is 6, B says 10, C says 7, and D says 9. So your answer is A. All right. So question number 3 now. Question number 3 says, find the derivative of y equals to 1 over 3x plus 6, all brackets squared. Okay, we should find the derivative of y equals to 1 over 3x plus 6 all squared. Okay, so we have 1 over 3x plus 6 all squared. Find the derivative. So this is written thus as, let's say we have y, which is an equation, is equals to 1 over 3x plus 6 all what? All squared. Okay, so we should find the y, the x. That's what they are saying. You should differentiate. It's the opposite of what? Integration. So You have options though. You have options. You can do it by your function of function, or you just expand this. So when you expand this, you do it with your first principle. So we have, if I'm using my function of functions, which says if y equals to this, then I'm going to make this to be equals to, I say let u be equals to 1 over 3x plus 6. Okay, so therefore y is equals to u square. Okay, now I'm not going to differentiate u with respect to x. So I have y equals to u square. Now, so if I differentiate u with respect to x, I'll have du dx is equals to okay, now I didn't tell you that when you are differentiating is the opposite of integration. If you have y to be equals to x raised to power n, then your dy dx is equals to n times x, then n minus 1. You are going to multiply the power by the coefficient, then you subtract the coefficient by 1. Then this is the same thing as, let's say you have y to be equals to axn, then your dy dx will be equals to a times n, an, then x raised to power n minus 1. You multiply the power by the coefficient, then you subtract the power by 1. Similarly, if you need an in-depth knowledge of this, if you don't have an idea of how to differentiate, just feel free and go to the subject by topic area, look for the differential calculus, and then we'll give you details of differentiation there. Okay, now let me come back to this question. So we have u to be equals to this 1 over 3x plus 6. So if I differentiate this, it's going to be, you know, the power of this is 1. Okay, then this one too has a x beside it, but the power is 0. The same way we solved question number 1, has a power of 0, because any number raised to power 0 apart from 0 is what? Is 1. So now you multiply this power by this coefficient, which still give us 1 over 3. Okay, then you subtract this power by 1, then that gives us x raised to power 1 minus 1. Okay, then plus you multiply this power by this 6, that gives us 0. Then you have 0. Then you have x raised to power 0 minus 1. So this is equals to, forgive me if you feel I'm breaking it down too much, but believe me, there are guys that will enjoy so you have 1 over 3 x raised to power 1 minus 1, then you are going to have 1 over 3 x raised to power 0 plus this times this, you have 0. So x raised to power 0 is 0, then you have 1 over 3. Okay, so because x raised to power 0 is 1, 1 times 1 over 3, you have 1 over 3 plus 0, 1 over 3. So your du dx equals to 1 over 3. Okay, now your dy dx is equals to dy by du times du by dx. So because if you're taking JAMB, you should have this handy, because you don't have the time to be solving questions like this, breaking questions down like this. It's okay if you solve this in your theory questions like WAEC, but it's not okay if you do that in JAMB, because it's going to hit out of your time. But if you have this handy, you can just jump straight from this equation to this equation, from here to here, and just solve it. But I try to break it down so that you can have a bit of background. Now you have your du dx, which is equal to 1 over 3. You have this. Now you need your dy by du. Okay, so your dy by du is, you come back to this equation where you have y equals to u square, this equation here. Okay, so you differentiate this with respect to u, so your dy by du equals to, the same way, 2 times 1, that is 2, then u then 2 raised to the power minus 1. Then this gives us 2u. 2 minus 1 is 1. U raised to the power 1 is still 1. So it's still u. So you have 2u. Okay? So which means that the y by the x equals to the y by the u, which is your 2u, times the u by the x, which is 1 over 3. Okay? So you have 2. Now you substitute your u back. Remember that you said let u be equals to this. So if you substitute your u back, you have 2 into 1 over 3x plus 6 times 1 over 3. Then invariably what you're saying is you have 2 over 3, because 2 times 1 over 3, you have 2 over 3 into 1 over 3x plus 6. That's what we've got. 2 over 3 into 1 over 3x plus 6. So if you look at various options, you have option A says it's 2 into 1 over 3x plus 6. B says it's 2 over 3 into 1 over 3x plus 6. And C says 1 over 3, 2 over 3 into 1 over 3x plus 6 all square again. And then D is 1 over 3 into 1 over 3x plus 6 all square. So your option is B.